All right, here we have an example of a graph, and we need to find the equation of that graph. So this looks like a secant or a cosecant graph. The first thing we want to do is to try to figure out the corresponding sine or cosine graph that goes with it. If you think you have an idea how to do this, I would encourage you to pause the video, give it a try, and then restart the video and see what you came up with. Okay, so first thing I want to do is determine the asymptotes of this graph right here. So let's draw those in. Alrighty, so it looks like the asymptotes would be here, where I have these orange dotted lines. Now, since this is a secant or a cosecant graph, then we know that we could find the graph of the associated sine or cosine, or the equation of the associated sine or cosine graph, and use that to write the equation of our secant or cosecant graph. So wherever we have the asymptotes for our blue graph, that's going to be where the associated sine or cosine graph is 0. The reciprocal then being undefined. The other thing we know is that the sine or cosine graph is going to share these points. And we talked about why in a different video. So I can start to see then where my sine or cosine graph, which we'll talk about here in a second, is going to kind of go like this. So if we can find the equation of this red graph, then all we have to do is change to the reciprocal function, and we'll have the equation of the blue graph. All right, so to figure out the equation of the red graph, we need to figure out the period and the amplitude in this case, because there's no shifting up, down, left, or right. So let's look at the period. So let's find a period of this graph. I'm going to say if I start at 0 and I go like that, it looks like maybe that's a period right there. So it's completing a period in 1, from 0 to 1, a space of 1. And we know the period is 2 pi over omega. So maybe we should write this out. What we're trying to figure out for this red graph is omega and a. So it's going to be a, and then either sine or cosine, we'll figure that out in a second, omega x. So we're trying to figure out the values of a and omega right now. And that's going to come from the period. So if we multiply both sides by w, it looks like we're going to get, or omega I should say, we're going to get 2 pi equals omega. All right, easy peasy. So that is 2 pi. Okay, now we need to figure out the amplitude. So recall that the absolute value of a is the amplitude. And the amplitude is basically half of the distance between the highest and lowest points. So our highest point is occurring here at 2, and our lowest output for the red graph is occurring at -2. So that is a distance of 4. That's a distance of 4, and half of that is 2. So I know the absolute value of the absolute value of a is my amplitude, which is 2. And my a could be positive or negative, depending on whether I need my graph to reflect over the x-axis. And it looks like this is a cosine graph that hasn't been flipped over the x-axis, right? So I think we're going to be doing cosine. And we're not flipping over the x-axis, so our amplitude is going to be 2. Okay, let's put this all together for the red graph. So my red graph is y equals 2 cosine 2 pi x. Awesome. So now, since this blue graph is the reciprocal function for that, which is secant, then the blue graph is 2 secant. Just keep everything else the same and just change it to secant, and boom, we have our equation.